If you want,
It is 7:30.
we're live.
All righty, we are live. Welcome, everyone. Happy New Year. This is the first meeting of the year of the Warren Astronomical Society. Welcome back. Typically, we hold this meeting at Cranbrook, but historically, there's been precedent for us being snowed out, so we opted this year to do it online, and as luck would have it, it's 40 degrees out and dry. Oh, well. So here we are, online for our Cranbrook meeting. So let's start off with officer reports. The president report is I don't have much to report. I'm the new president, and I left Dale with a stinking heap, a lot of work to do. So let's go to the first vice president, Dale Parton.
Okay, thank you, Bob, and Happy New Year, everyone. I'm working to get speakers for this next few months. I do need a speaker to give a full-length presentation on February 16, and also a short presentation on March the 6th. And I can tell you that our next presentation, or at our next meeting on January 19th, I'm going to be giving a sort of belated presentation on the Christmas star. So I'm looking forward to this year, and if anyone has something you've been thinking about that you might like to present, either in a 10 to 15 minute time frame or a 50 to 60 minute time frame, please let me know. We need you. Thank you.
Thank you, Dale. Jeff McLeod is our returning second VP, observatory chair. Probably don't have a whole lot to report. I can read off Riyadh's report from last month, Jeff.
Wonderful.
All right, so Riyadh emailed in December that the observatory was opened at 5:16 p.m. Sky was cloudy. Thanks to Mr. Brandon, I'm going to get this name wrong, Lubera, who attended the open house and donated 3 eyepieces and a Barlow. Wow, these eyepieces are a welcome addition to our observing tools. All equipment and both buildings are in good condition. The sky did not improve, and it started snowing about 6:30. The observatory was closed at 7:15. Sigh. So I'd like to thank Jeff McLeod is returning, and so that's pretty much it. So we had pretty much a snowy open house last December. When is the next open house, Jeff?
Fourth Saturday. If you need a date, that's going to be the 28th.
All right. So on the 28th, our observatory will be open. Come on out and have a look at the skies. Treasurer Adrian.
I think Adrian's away. He sent me a message.
He's bowling.
Okay. I got his report right here.
Okay.
Just under 30K in the bank, near 1,000 in petty cash, near 500 in PayPal, 400 after he paid me for the business cards. Please renew your membership and consider joining Astronomical League.
Awesome, thank you. Secretary Mark Kedzier.
Happy New Year, everyone. The minutes of the December meeting are in the WASP, and there's a total of 6 calendars left if you want to order one, the WASP calendars for 2023. That's my report.
Thank you. Outreach, Kevin.
Hello all. Just for outreach, we're looking at some outreach events next year with the Metro Park system, and going to be contacting Steve Seberg from the Metro Parks, and the Veen Observatory that Gary Ross works with a lot is closed until March, and that's about it.
Okay, thank you. Just expanding on that, we're going to be we've been contacted by Steve Seberg. He's our rep with the Metro Parks, and we've kind of because of COVID lost contact with them. Well, they want to reestablish contact, and Metro Parks would like to have a couple observing events during a meteor shower next October. They didn't even bring up the Perseids, which is kind of odd. So when we have a meeting with them, we're going to be talking about doing more events at the metro parks, and I would like to see us do events at like Metro Beach, which is really close to me. 'Cause we used to do events there. We used to do events all over the place. So we'll be contacting them. Publications, Dale.
Well, Happy New Year. I'm pleased to report that the first issue of the New Year's Wasp is online. And getting ready to send out the annual mailer to let everybody know what their membership status is at the time. So watch your mailboxes the next couple of weeks.
Yep. So yeah, time to renew your membership. If you haven't, you can pay via PayPal by clicking on join on our website. One of the things that we've been doing, because we are now hosting these meetings online and at Cranbrook, both online and in person, uh, Adrian has been putting a lot forward and working as the AV guy. Well, we need somebody to either help or take over that position. If anybody is interested in assisting setting up the AV equipment at these meetings and learning how to do that stuff, that would really be helpful. Is anybody, we had one member before we started here say that they have some things to sell. If there's any members who have any things that they'd like to sell, let me put something in MailChimp. We could put something out. The Ford Amateur Astronomy Club, they have a swap meet in March time frame, and our picnic in August. We can also sell stuff. But if you have a list of things that you need, we could send a MailChimp mailer out to the membership if you have stuff you'd like to sell. So if you have stuff to sell, just put something in the chat, and we'll see if we can get a mailer out. Okay, that is it for the officer reports. Do we want to start with observing reports? Anybody have observing reports?
Yeah, I got Riyadh and I went out to Stargate to watch the occultation of the moon across Mars, and the moon was occulted by the clouds. So we were completely clouded out. It was just the two of us out there, and it was annoying to some degree, but apparently across the country it was seen at certain points. Even Adrian was able to get a really nice shot of it as the Mars was coming out from behind the moon. Um, it was it was unfortunate, but that was one of those things that happens. Uh, the other observing report that I have is, of course, the lunar eclipse that occurred. Mentioned this before. I took my grandson out to a park that had real nice skies at it. Police officer stopped by and was wondering what the hell we were doing there. And I just pointed to the moon, and he said, "Wow, that's really cool." I said, "Well, it isn't quite total yet, but stop your police car in a few minutes, and go take a look at it, and you'll get a kick out of it." "Oh, I'm going to do that. That was really great." Now, as soon as he left, this was at Drake Park. It's a softball park. It's got pickleball and all kinds of other things at the park. As soon as he left, the lights went on in the park, all over the park. It didn't really affect us too much, so we just drove over to another place where we were able to see it. Very, very nice, and it was a nice display this time. Absolutely. Um, so there you go. That's the two observing reports that I can give you. Like I said, the lunar eclipse was great. The occultation of Mars, it occurred.
Not so much.
But
Well, yeah, it was occulted, all right.
yeah, that's what they tell me. All right,
Michigan Astronomy.
there you go. That's my observing report.
Anybody else have any observing reports? Well, I got my granddaughter for her birthday one of those projector things, and it projects like a moving nebula and laser stars on the ceiling, and she was freaking out about it. So, make an astronomer of my granddaughter yet. Any other observing reports? Crickets, crickets. All right. Well, then they got special interest group. I haven't got my solar stuff up yet, so let's go to Double Star. Riyadh, any Double Star reporting?
Yeah, hi. Yeah, actually, because of the weather recently, I don't have much to report. Um, However, um, we have received the spectroscope filter that I purchased recently. And once we find out which size camera we need and we have one to try, then we'll be able to use that spectroscope to look at all kinds of stars, and we'll even try to see if we can figure out some double stars, maybe just using the spectroscope. So that hopefully something will be coming up this summer and or this even spring, and maybe with the according to what the program will be with Jeff McLeod being in charge, hopefully we will work to be able to use the new equipment. So stay tuned, and we'll be having some actual hands-on work to do. Thank you.
Thank you.
There's one other thing, if you don't mind me adding this real quickly.
What do you got?
The moon is going to occult Jupiter this year, apparently twice. And I thought I would just put out to Jeff that maybe we need to take a look at those nights and see if we can take a look at that with the moon at the with the scope. That would be really kind of cool. That's all.
Everybody see the sun right now? See the video? Hello?
Looks great.
Okay, yeah. Well, this is ultraviolet view of the sun, and as you can see, the northern hemisphere is flaring like crazy there. I have an app on my PC I installed from spaceweather.com. It alerts me to solar flares. My phone has been buzzing like crazy recently with flares going off. There's also, let's see if I can switch over to back over to here. And there is sunspots. We've got, wow, look at that, peppered with sunspots everywhere.
Yep.
So that is solar. Sun is very active and flaring like crazy.
Yeah. Coronal mass ejections, do we know?
I'm sure there have been. I've been seeing some pretty big flares. Again, that spaceweather.com thing will fill up your phone with stuff lately.
Yeah, that's what they say. Yeah. That's cool.
So back over here, any other observing reports? Negative. All righty.
Yeah. Adrian did mention that he caught the Mars occultation.
All right. Any of our astrophotographers have pictures to show that they've got in the last month? Oh, come on, guys. It's going to be a slow meeting if you know nobody has any pictures.
Oh, I got lots of pictures for you today. I got lots of pictures.
I've got pictures, but unfortunately, not new pictures. If you looked out your door lately, it hasn't been very clear the last month or so.
Yeah.
I got some great pictures from older stuff I've got, but I'll show them another day when I've got more time.
Okay. So, well, it's a little early because usually this thing is filled up with pictures, but we could do the short presentation now if we'd like to.
I don't know whether she's here yet. Is she here?
She's here.
Yes,
Good.
she is.
Great.
Hi there. Alrighty, well, if you're ready to start.
Yes, we're here.
All right, Dale, let's go ahead and do it.
Okay.
Okay, let me just say that our speaker is Stacy Welborne. I understand she's 19 years old, and she tells us that she has cerebral palsy and epilepsy. She became a volunteer NASA Jet Propulsion Labs Solar System Ambassador, I believe in 2021. She's written a astronomy curriculum for elementary school. And her topic tonight is how a young woman with significant disabilities became interested in astronomy. So Stacy, let's hear about Stacy's amazing astronomy. You're on.
Hi, everyone. First of all, if you don't understand what I'm saying, my mom is right here and she'll clarify anything I say if you can't understand it. But anyway, here we go. So, what is the real reason I'm interested in astronomy? But I don't want about it to see this at this point, right?
Yeah, I think you do.
Yep.
Can you hear her okay?
Yes.
Okay, good, good. Go on.
All right. So the first big thing I did with astronomy was going to check out the Venus transit on the sun in June 5th of 2012, which was so cool. If you look at this big yellow thing, that's the sun. And down here, that tiny dot, that's supposed to be Venus. And that was the coolest thing I saw. I totally fell in love with astronomy on that day. Jump ahead a bit to 2017. I got to check out the total solar eclipse down in Tennessee with one of with was it Jay Ryan?
Yeah, Jay Ryan. If anyone knows Jay Ryan, out of Cleveland, we were down there at a party that he was hosting, and I had proofread some books for Jay Ryan, and he said, "Come on down to the party." So we went down. It was, I won't say it was really cool because it was actually about 107 degrees that day, but
Interesting.
yeah, it was
really
very interesting. But during the eclipse, boom, the temperature dropped down to about 95 in just a couple of minutes. It was really, really amazing when that happened. Back to you.
Yep. So then I decided, ooh, I like astronomy. What happens if I want to try teaching this? So at first I just wrote the curriculum. It just so happens that my neighbor is the teacher at the fifth grade classroom of the local elementary school. So she was like, yeah, you can come over and teach in my classroom. And so I did. Here I am getting my first lesson set up. Stars are not cool, by which, of course, I mean this is about the temperature of stars. The sun is over 6,000 degrees Celsius, and it was the coolest, relatively speaking, star on the in the first lesson. I also had like bacon, and that was, let me
Okay.
check real quick.
She's checking a lesson plan here. Hold your book up so they can see. This is the basically the curriculum. She did it as a service learning project for child development 4-H. Are any of you involved with 4-H? Yes, no, maybe. Anyway, she wrote it as she wrote the curriculum as a child development project. During her junior year, she outlined it and lined up resources, and then her senior year, she actually wrote all of the lessons, wrote the PowerPoints, actually taught it as a service learning project, and yeah.
No, I did not list the temperatures and sizes of the stars.
Okay.
Oops.
All right. Well, it's in PowerPoint. I know it is. All right.
Yeah.
And there she is teaching the fall constellations. She had her own uniform. It says Stacy's Amazing Astronomy on the bottom, but it's tucked into her skirt. So, and
Here we are doing a hands-on moon phases lesson where you take a handful of Oreos and scrape off bits of the icing and how much icing you scrape, how much icing you have left is dependent on the phase of the moon. So then we did
My wife did the same thing, that Oreo phases of the moon in her classroom.
it was hands down probably the favorite activity of the year. This one was probably second.
You take a flower, move out the flower, then you take several bulbs and toss them in. The bulbs bounce up and create these little craters. Now we're taking a closer look and discussing them.
The girls were very delicate with their craters. The boys were like bombing the moon.
Yeah. Then we got to make our own satellites after we talked about the Voyager spacecraft, so they could talk about what they want to use to explore other planets.
Yep.
And then we topped it all off with a rocket launch. And by the way, the nice man with the green hat and the blue suit, that's my father. He's a certified rocket safety instructor.
Somebody needs to mute. We've got some feedback.
Yeah. Is it okay? All right, I think we're right.
Yeah, we're good now.
Yeah. She was just saying that the nice man is her dad. He used to teach rocketry and gun safety at the Boy Scout camp up in Michigan, where he went to camp for many years. And her project
got sweepstakes at the Indiana State Fair. I was the recipient out of all the projects they saw. I had the best display. And here is the host ranking sheet. Blue means you great job, you've met the standard. Champion means you excelled and are at the best and are the best project in your division. State fair means we think you would do really well at state fair. Even if you get champion at county level, that does not automatically mean you get to go to state fair. Sweepstakes means number one in the entire child development project at county level. Then again, blue means you've met the standards. Gold, you've excelled at the standards. And sweepstakes.
at the state fair.
Yeah, at the state fair, which was a goal I had, but wasn't my intention. I wanted to so what I could do, not get sweepstakes.
Carry on.
All right. Then, on the way during my journey, I actually got in contact with a man named Mr. Charles Fogo. He is a NASA Solar System Ambassador, and he was like, "Hey, Stacy, this sounds like something you would be very good at. Do you want to apply?" And I was like, "Yeah." And so I got my acceptance letter.
Just over 1 year ago. Yeah, It was the end of December last year that she got her acceptance letter. She was so excited.
Yeah.
Congratulations.
Yeah. Remember when there was that comet that could be seen by the naked eye? A telescope if you were careful back in last December. I tried to show some friends of mine that have a really great dark sky, but I couldn't do it. I came home the next day. I saw the acceptance letter.
Very good.
So there are several reasons I was chosen. I had proven my passion and my teaching skills. I also have great diversity points. I am a 19-year-old female with disabilities. That the female thing is common, but with disabilities, that is very rare nowadays. Well, nowadays, it's always been rare for people with disabilities to speak out. As I live in an underserved community, Franklin County is one of the states least likely to get government funding. I also submitted great plans for activities in my community.
Now they know the duties of solar system ambassadors because there's a couple of them there.
Right, let's skip that. I just skipped the whole what's about NASA thing.
Probably. She did this presentation at a Rotary meeting right before Thanksgiving. And so she had that in there about what's going on. And she talked about the James Webb images and how cool that was.
So far, I've done 2 TV interviews. I've had hundreds of casual conversations with some of which were with local students like the kids I mentioned. Then the next day, one of the kids I did the counseling with went to her mom and said, "Mom, I want to get binoculars for Christmas so I can be in someone just like Stacy is." Also, there's another program I'm involved with called Miss Amazing, and I tied my Miss Amazing in to my NASA work.
Does anyone know what Miss Amazing is? Has anyone heard of it?
No, I haven't. What is it?
Okay. Miss Amazing is probably the most appropriately named organization I've ever had the pleasure of knowing. It is an organization, a character development and leadership development organization for girls and women with disabilities. However, it is cleverly disguised as a pageant because who doesn't love sparkly dresses and tiaras? At Miss Amazing, the girls have interviews and they do community service, and it really encourages girls that most of society overlooks. It encourages them to get out and advocate both for themselves and for the disabled community as a whole. Stacy has been involved in Miss Amazing for 8 years now, 9 years. 8 years.
9.
Yeah, I'll be 9 in this next spring. And it has totally transformed her. She used to be what we called the Velcro kid because she wouldn't go more than just a couple feet away from me. But now she gets out and she speaks in public groups, and she's out there working hard. And Miss Amazing has really helped her develop the leadership and public speaking skills that she has. Okay, so.
Part of Miss Amazing is doing a presentation where you come up on stage and share what your passionate about. Obviously, I had to do astronomy, so would you like to hear my passion presentation for everybody?
It's just a 90-second presentation that she gives on stage. It used to be called Talent, but now they call it a passion presentation. So yeah, go on. I'll do your slides. Okay, so she presented this in April here in Indianapolis, and she won. She is the
You were supposed to say that.
well, hang on. She's the Indiana Miss Amazing Teen 2022, and in July then she went down to Nashville, Tennessee for the National Miss Amazing pageant, and she presented it again there, and she got first runner up. And so she did really well as a solar system ambassador and a Miss Amazing ambassador as well. So here is her passion presentation. Where'd it go? There we go. Okay, reach for the stars.
Hello, everyone. Thank you all for being here tonight. Ever since I was a little girl, I loved looking at the stars. When one day a man with a telescope, much bigger than I was, told me something amazing. I fell in love with astronomy that day. I love the sun and planets and rockets and, well, you get the idea. And now I work with NASA. Yep, you heard me right. NASA. Me, at only 19 years old with cerebral palsy and epilepsy. I am that now an officially endorsed NASA Solar System Ambassador. As a NASA Solar System Ambassador, I teach community groups about astronomy and space exploration. Last year I taught, 2 years ago, I wrote an award-winning astronomy curriculum, which I taught for a full year at a local fifth-grade classroom. The kids loved it.
Award-winning curriculum. Go on.
Right. It's been challenging because of my disabilities, but I believe that women like me should not let the disabilities get in the way of reaching for the stars. I didn't, and you shouldn't either. Which stars do you want to reach for today?
And there she is being crowned the Indiana Miss Amazing Teen. And there she is winning first runner-up at Nationals. Okay. Does anyone have any questions for Stacy?
Yeah, I do. How old were you? Well, when you saw that 2012 Venus transit.
Let's see, that was back in
June of 12. She was 8 years old.
And before that, how much astronomy did you know?
Only what Mom dragged her out of bed to see, because I'm pretty famous for getting them up at like 3 in the morning to go see meteors. So,
But seeing the Venus transit changed the course of your life.
Yeah, very much so. She understood. I mean, science class, we homeschooled. She understood the planets, and she understood that. But that moment, it really was amazing watching her. And the man was so cool. He told her, he said, "Sweetheart, only through astronomy can you hold the sun and Venus in your hand at the same time." And she was just, wow, that was so cool. And she just kept looking at that and was just amazed at the prospect. And after that, she started seeking it out herself, checking out astronomy books from the library, I had
Awesome.
several of my father's astronomy books, and even though they were adult level, she was reading them. She would watch videos on YouTube. She started teaching herself her sophomore year of high school. She took astronomy as an elective and really took off with it at that point.
So I would like all of our outreach people to be aware of this. People looking through your telescopes can change their lives.
Yeah. Oh, yeah. So that picture of her climbing up on the footstool and then even stretching further to get up to the eyepiece. I mean, the telescope was probably 4 times bigger than she was, but that whole event just, it changed her life. And when she showed you the picture of Charles Fulco, long story, I did proofreading for Michael Zeiler. Does anyone know Michael Zeiler? He wrote, he's the Great American Eclipse guy, the website Great American Eclipse, and he does a lot of the maps for the eclipse. He had a book back that came out in 16 that I proofread for him. When she wrote her curriculum, I sent it out to a bunch of my teacher friends and astronomy friends, Jay Ryan, Michael Zeiler, a few others. I see a hand, we'll get to that in a second. And Michael Zeiler said, I don't know anything about teaching, but the eclipse lesson looks pretty good. And then he forwarded all of that onto a friend of his who is a teacher, and that's Charles Fulco, and he is also a solar system ambassador. He kindly went through all of the lessons with Stacy via Zoom. He could have done it in probably about 3 hours, but over the course of about a week and a half, they Zoomed for more than 10 hours. And he spent so much of that time quizzing her and finding out how much she knows. And at one point, I'm over here taking notes on the other screen. And he said, "Good job, Mom." I'm like, "Oh, it is not me," because she's way beyond what I know on astronomy. She is a give a kid a good book and get out of the way kind of learner. And she's just always been that way. How do I answer that hand? Joanna, you got your hand raised.
Yeah, Joanna, you can unmute, ask question.
Joanna, do you have a question? Maybe, I don't know. What am I supposed to do with that, Bob?
I don't think there's anything you can do. Joanna, you need to unmute and ask your question.
Maybe. Does anyone else have
Anyone else have a question?
Actually, I'd like to congratulate. This is a wonderful presentation you're doing. I'm also a solar system ambassador, and later on, Bob Tremblay, who's also on the club here, he's also solar system ambassador. So I'm probably, if I get a chance, the next few days, I'm going to try to write a little message to you through the solar system ambassador group. So
Okay.
keep on doing what you're doing. You're doing a great job.
Fantastic. Look for my name, Annie Welborne. She has trouble typing, and so she doesn't have her own Facebook. If she wants to look at anything on Facebook, she uses my Facebook page. Now she does have her own, let me pull it up here. She does have her own Facebook page for astronomy. Let me pull that up.
Yeah, if you could post that link in chat for us.
Yeah, when I get
great.
there. For
Thank
some
you.
reason, my computer's not being real cooperative tonight. And she posts, it's called Stacy's Amazing Astronomy Club. Let me share again. Let me pull it over here.
I wanted to add something if I could at some point.
Go ahead,
Can you
Ken.
hear me?
While she's pulling this up, go ahead.
That's what I want.
Stacy, have you ever met Fred Espenak?
We have not, but we hear he's
I
involved.
will make sure that I introduce you to him. He's one of my best friends.
Wow.
Absolutely.
Mr. Fulco told you about him, and he's involved in no.
He was a
He's
East Coast
Mr.
known as
Eclipse.
Mr.
He's the one
Eclipse.
he's out on a cruise on the Arctic or something right now, I think, isn't
Yeah, I
he?
know. Yes,
Okay.
he's a
I'm
very
thinking
old and
somebody
dear
else
friend of mine.
that's involved in 4-H. Anyway, this is her page, and she posts, go on down, she just posts things that she finds that's cool. We have plans for her page this year in that our family has experienced a lot of turmoil the past couple of years because my husband has gotten pretty sick. And so a lot of our grand plans have not come to fruition this year. But we hope that 23 will be the year that we can start doing more things with her astronomy. She wants to occasionally interview people live for her page. So we may be hitting some of you up for that.
Here
But
we
right now,
are.
she just posts things that she finds and shares, and people are interacting with her page. Lots of people have been asking her questions, both on my Facebook page and hers and in person. Hey, I saw you posted this. I didn't understand it. Please explain it to me.
Like, for example, when the Mars InSight lander sent in its last image, it wrote in first
Ooh.
person. So somebody was like, wait, it's a machine or a person? Then I explained it by saying it's a machine, but it reports with first person text.
Yeah, so she answers questions, and it right now is just taken off. Who knows what it's going to be in 23? Don't know what's going to happen with it. We're having fun. Oh, scroll down. She's lately obsessed with there's a girl named Lily Hevish who sets up dominoes, these great big domino things, and sets them off, and she did one for NASA. And so it's really cool. And so she watches a lot of Lily Hevish videos on YouTube as well. So any other questions?
I post an astronomy of the week every week. I'm gonna connect with you, Stacy, and
Oh, cool.
get a chance to share with that. I'll
Here's our,
befriend you.
let me put this into chat.
Thank you.
Let me find chat.
Okay.
Honestly, I've never used WebEx before, so
Just to hit the stop
hit
button.
stop. Yep.
Chat should be in the
Chat.
lower
I see it.
left or lower right. Yeah.
There it is. There you go. There's Stacy's
Alrighty.
page.
Thank you.
You're
Good.
very welcome.
We got her. Very good.
Yeah.
Perfect.
Prior to just 2 or 3 months ago, I did all of her typing on her page, but she's trying to take more of that over. But I will say one of her disabilities is that she has a funky form of dyslexia where she can read and understand anything, but it's really difficult for her to spell correctly. She's learning to type things over in Word first and then copy it over into Facebook. So if you see something misspelled, it's just part of the package. So,
Don't worry about it.
yeah.
Nothing to worry about, my
Right.
man.
Have you ever heard of Orton Gillingham?
Yes. Yes.
My wife teaches that.
Okay. We've, I don't remember what we had you evaluated. It's not that kind of a, it's not that kind of a spelling thing. Yeah.
What did expressive
There's the value.
function was?
Yeah.
What they finally managed to say it was, but
Yeah.
basically it was, we have no idea.
Yeah. The double MD PhD down at Riley's Children's Hospital down in Indianapolis couldn't figure her out because she was recognizing everything as correct spelling, but not able to produce it herself.
Way to go.
All right.
Any
Anyone
other
else?
questions for Stacy?
Kelly, thank you for following.
All right. If we have no more questions, we gotta let's thank our presenter. Thank you very much for saying. Thank you for teaching kids Very important,
We-
and we're
Wait a
thrilled that astronomy affected your life
Focus on
Yeah.
amazingly.
It's not just kids.
this
She's
before.
been teaching people. She's been teaching grown-ups as well.
Awesome.
Like I said, she did a Rotary Club meeting back in November. There's one guy at church that frequently stops and asks her about things, and so she's teaching adults too.
That's neat.
She's a good teacher. So thank you very
All
much
right.
for having us.
Thank you. And it's time for our break. Let's take a 15-minute break and meet back up at 8:30 for our full presentation.
All
And
right.
have a break, everyone. If you want to stick around and talk astronomy, stick around and talk astronomy for the next 15 minutes. Oh, wait, before we go, hi there. I just saw David Levy. So let's have David Levy do his thing. Hi, David. Can't hear you yet.
You're muted,
There you-
David.
You're muted, David.
Cannot hear you.
Still muted.
Still muted. He's got the same microphone I have.
Yeah, I fought with mine for about an hour with Dale today.
Still can't hear you, David. Not using the microphone. Not using the right microphone. There we go.
He's not muted on the thing. It's
not
coming through. He's open.
Maybe he has the wrong mic selected.
I think that's what's going on.
Maybe we should take a break and when.
Yeah,
we
we'll
work
take
on
a
it.
break and come back at 8:30 and
Aviv will get it straight and we'll do it
Yep.
then.
Okay. We will not be back because I
All
have to
right.
go to bed. I start teaching at 5 a.m. in the morning. So
Yikes.
yeah, I teach
Thank you
English
very
to kids
much.
on the other side.
Thank you very much,
you.
and good luck, Stacy.
Thank
Good
you.
night.
Bye.
Bye-bye.
Thanks a
you.
bunch. Well done.
David, you may have to drop off and come back on.
Sorry.
Yeah, because that's what I had to do. I had to get off and come back on, and then it connected me up just great.
Can you hear me now?
Yes.
Mm-hmm. Yes.
Okay,
Hi there.
great. Okay, so I'll come on back at the end of the break.
That's good. Dynamite. You got to see you saw the occultation, didn't you?
Yes, I did. I enjoyed that very, very much.
Yeah, we got to see the bottom of the clouds. We got to see.
Gotta love Michigan.
Hey, I got to see the eclipse and the occultation. I got lucky.
we did not get lucky here.
So Adrian, so you have an SQM meter now?
Yes, I do.
And you just stop by my house. I'm curious to see what my skies are. After
You
reading
got
your
it.
article, I fear that I might no longer be Bortle 5. It is what it is, obviously, but
You're going to be at the bottom end of Bortle 5, if nothing else. It's a surprise what Bortle zones are. You know, where I go at Alcona County, it's Bortle 3. As you can hear, I've got a lot of noise around me, so I won't talk much. But yeah, it surprised me. Zones that I thought would be Bortle 3 were Bortle 4.
what is the Point Bark?
Marino, it's
park?
10% Marino.
Middle of Bortle 4.
Is it really?
Yes.
Wow.
Yeah, it's 21.1, which is near the middle.
That's a shame.
Yeah, we're losing our darkness pretty quickly. but the sky still looks brilliant. So it's, you know,
Well,
it's
yeah.
not like, you know, Bortle 4, you can get sky glow.
Well, it's just another reason to appreciate going to a truly dark sky.
Yep. And those are high Bortle 2. They've given Bortle 1 to completely black skies. At Kenton, Oklahoma, you'll see gray in the sky when it's like peak darkness. And I see it in my images too.
So
If you
Bob
look
Burner,
at
I
your,
see something there in the background. Is that your AM5?
oh, you're talking.
Yes. Yeah, Dale.
So we've had clouds. Have you got a chance to test it?
No, I've gone through everything works perfectly. I've gone out and get everything run. Everything works perfect. I can do all the various options on it, and I can set it up with the, what do you call it, off your home internet, then tying in off of that. The station, I've got a station mode set up and everything else.
Yeah.
Actually, I was talking to Dale Parton, and I was suggesting that maybe you and I might want to do a talk in the upcoming few months about new technology for astronomy, covering things like this, both the gear we have, and also the use of the narrowband filters to cut through the light pollution that we're all just dealing with, as we just talked about the various Bortle unbright good skies for us. So might be something we want to do with maybe two of us can work out something together.
Well, I've actually thought about doing a presentation on simply ASI air and how it's a game changer and made things easier for me. But I just simply haven't had a chance to go ahead and make a presentation. Life's been too busy. But speaking of narrowband, so one of those images of Mars that I submitted it to ZWO, the manufacturer of the camera, and won one of their contests. And I didn't come in first place. I come in 9th, but the top 15, you got 10% off. And that's what I was going for, 10% off coupon, because I was going to buy something. So you think 10% doesn't matter much, but the cost of cameras was expensive. I saved hundreds of dollars, but I'm going to a full monochrome setup. So you're talking about narrowband. I just spent like $1,400 on narrowband filters. It's crazy. But yeah, so I was colors, and now I'm going to full monochrome setup. So that'll be a new realm.
Yeah, I'm doing the opposite. I've always been narrowband for a long time. I'm still doing all the narrowband, but I wanted to get into
your
color.
stuff.
Yeah, I want to do the color with the various, the triode filters, that type of thing, from the color, trying to simplify. My whole goal is to make a really portable setup, fast you can set up and not spend hours and hours hauling it around, hundreds of pounds of gear and everything for traveling.
Well, I agree. I wanted a second cooled camera because I have multiple telescopes and multiple mounts, and I really only have the one big camera. So I got basically the monochrome version. I wanted to put and you're right, take the cooled camera and put it on the portable setup, but I wanted a second one to do, I don't know, more serious imaging. I don't know what that means, but just have more control of the workflow, I guess. So, but
on the other hand, you go the ZWO site and they have the 11 people which they've picked out to highlight. The set those guys are getting is phenomenal.
I saw a picture on Facebook today of Andromeda Galaxy. It's like, I wonder if that picture is better than mine. It was taken with the DSLR. It was amazing. So you don't have to mortgage your house for equipment to get good images, I guess. But it's good that people are having fun with whatever equipment they have, obviously.
Anyway, I'll contact you offline and we can maybe talk about, so we want to put something together later on, maybe some sort of a dual presentation or something.
I'd be happy to do that. It's just coming up with stuff. But yeah, I have some ideas.
Yeah, Dale Parton's been harassing me about doing something like that. So.
I'd be happy to help.
Guilty as charged.
Now, we can't give too many of our secrets away. Because everybody would want to do it.
We're getting some converts. When I'm a member of the San Francisco Amateur Astronomers. I've been there for many, many years, still am. And when I started in that club, I was the only astro imager, and most of them could not see any reason to not put an eyeball to an eyepiece all the time. What do you need those cameras for? And now it seems like 60, 70% of those
Hello,
people now
Randall.
are also imaging. So I made some converts.
This is David.
Well, as we get older and our eyesight gets worse.
Yes, I
there's
got your
more and more
message.
reasons
It's
to do
David
photography.
calling. I got your message and I just wanted to say hello.
But quite simply, the reason is so I can share it with others.
David, we can hear you.
Is this better?
David, you're not muted, so.
Oh, I'm doing very well,
we can all hear
Randall. And or fair, I'd say fair. I'm still hoping that you'll
Gail,
get there
any
to
way you
see
can
me.
mute?
But I'll talk with you when you get back to Toronto. It might be better, okay?
Okay, he appears to be muted. So yeah, so when you do visual astronomy, it's great for you and anybody there with you, but you can't share that experience without a way of capturing that and translating that. EAA, photography, even sketching, or even telling people about it. You have to relay the information somehow. So, yeah. Of course, back in the day, it was so difficult to do astrophotography, right? Uh, Film and a lot of guesswork and trial and error and mostly error. But
And
nowadays,
staring for hours on end through a guiding eyepiece and for your manual corrections. And many of the day I went home the next morning, I couldn't move my neck. I was so sore.
So a friend of mine was showing me his photos of Hale-Bopp comet, and it was all done on film. And he took so many rolls and change the setting and see what that would do, and go out the next night, change another setting, see what that would do. And it took a long time to really sort of dial in what it needed. So just to close the loop takes a lot of effort for those sort of things. Nowadays we have instantaneous feedback nearly of your results, and you can tune them in. So yeah. So for my color camera, one thing I haven't done much is on my C11. I use it mostly for planetary imaging. So
2-minute warning.
Oh, coming up. So I was hoping to put my color camera on there. I'm ordering a new off-axis guider setup so I can get better guiding, lock the mirror down, and have an external focuser. So I'm going to try to set it up for galaxy season. See if I can get some of the smaller galaxies that are just too small for my small little refractors. It's field of view. So
Adrian, are you on? Can you hear? Adrian, I was wondering if Adrian was on and could hear. One of the things I'd like to do, and I know Adrian has imaged it, is the zodiacal light. I've never seen it, and I wanna. And I know he goes to like the thumb area of Michigan and has imaged it. I want to put that on my to-do list. I know it's visible in the spring and the fall, so spring is coming up. 1 minute warning until we start back up. Everybody, get ready for the main presentation.
I have to actually apologize because I got to cut out because I have to go pick up my son from work. So Ken, I'm going to miss your presentation, your group's presentation.
Okay. Just look at the
Actually,
recording.
we're gonna have
Do the
David.
recording.
We're gonna have David talk first.
And I can send it to you too. So it's okay.
You can send it to me. Okay. Bye, everybody.
Later. Thanks for coming.
Okay.
All right, we are coming up on 8:30, and I am going to have David Levy give his short presentation, talk, poem.
Well, thank you. I
There
hope
you
you
go.
can hear me this time.
Yes.
Great. Okay, I want to add my welcome to all of yours for this first meeting of 2023. Sorry to be a little late and sorry I forgot about the microphone. But tonight I'm going to quote from Tennyson with the remark of how amazing it is that so many English writers have become interested in the night sky. So tonight I quote from Tennyson, who wrote a very famous piece in Locksley Hall in 1842. He wrote, "Many a night I saw the Pleiades rising through the mellow shade, glitter like a swarm of fireflies tangled in a silver braid." Thank you very much, and back to you, Bob.
Oh, well, that was short. Thank you, David.
Thank
All
you,
right.
David. Good to hear
And
from you. I have to go back on mute, but I wanted to say hello to you.
all right, now it is time for our feature presentation, and I will pass the mic over to Dale Parton.
Okay, Bob. Those of us who have been in the Warren Astronomical Society for a number of years simply don't need an introduction of Ken Bertin, but for those who are newer, Ken has been an amateur astronomer for roughly 70 years. He was a president for a couple of years of the society, was awarded a Searle Award and also a lifetime membership to this organization. He's traveled to see about a dozen total solar eclipses and a bunch of other eclipses. He has given over 100 presentations to this organization and also speaks to other astronomy clubs, schools, and libraries. His topic tonight is an Astronomy News Roundup for 2022. Ken, you're on.
Okay, I just wanted to mention one thing important, that there were about, I'd say about 30 really top news stories this year in astronomy. And I've selected what I feel are the top ones at this point in time. If there are any other stories at the end of this presentation that you would like to add or like to ask about, you're certainly welcome to.
Only 30.
What's that?
Only 30.
Well, there were 30. There were hundreds of there were hundreds of them. But the point is that we wanted to select the very best. So I'm going to share the screen now, and let's see if we can get that done. Here we go. And
excuse me for a moment.
go ahead.
Would everyone else please mute so that we don't get any interference with when Ken is speaking? Thank you.
Okay, so here we go. You can hear me fine? Is everything okay? Does everybody see in the news right in the front?
Yes.
Good. That's all I needed to know. Okay. Well, 2022 was quite a busy year. The James Webb Telescope leads the list of the news stories of the year. It was a good year for astronomy. Images raining down from the James Webb continue to dominate the news cycle. We are treated to not just one, but two total lunar eclipses. Artemis was launched to go to the moon, to eventually take astronauts there, we believe. The DART spacecraft was crashed on purpose into an asteroid, redirecting it. What are we waving our hands for? Bob?
Unmute the DART mission. I'm freaking out about it.
Okay, all right, okay. And astronomers unveiled the first image of the behemoth black hole at the center of our Milky Way galaxy. But it's not all roses and stars. The National Science Foundation has decided not to rebuild the Arecibo. NASA discontinued the Sophia Airborne Observatory, and new satellites continue to crowd the sky, and they're getting brighter, not fainter. light pollution too continues to grow. Here we look back on the biggest news of the stories of the year, and let's get into it. The first story, the astronomers have made long made a case that the supernova blew up out the local bubble, a cavity of sparse hot gas around the sun. This year, a team of astronomers has gone further, determining the local bubble's origin in time and space. Tracking stellar motions back through time, they concluded it all started some 14 million years ago, when between 14 to 20 stars in the upper Ceteris lupus and lower Ceteris crus clusters went supernova. The sun now sits nearly at the center of the local bubble, but that's happenstance. Our star is 1,000 light years away from the supernova when the fireworks began and entered the local bubble only some 5 million years ago. Subtle bubbles like this one might fill the galaxy. As said, though expected, the final observations by the Sophia Observatory, which flew for years aboard a modified Boeing 747, represented a loss for infrared astronomy. In our coverage, we reflect on the gains Sophia has provided over the years, including the discovery of water on the daylit moon and the first type of molecule to form in the universe, as well as the reaction from the community. The magnetic field lines detected by the airborne Sophia Observatory are overlaid on a Hubble image of the Whirlpool galaxy M51. Surprisingly, the magnetic field lines in the outer arms do not follow the galaxy's spiral shape. Tense star formation in these outer regions may be caused by magnetic chaos, and the gravitational tug of the neighboring galaxy NGC 5195 probably also plays a role. Sophia streamlines NASA Sophia science team and such. Low orbit satellites are getting brighter. Satellites are being launched to low Earth orbit at increasing rates, leading to an ever more crowded sky. While SpaceX initially worked with let me do this here. That's important. I'm sorry. As a result, the Starlink satellites have become brighter again. They are still dimmer than the original design, with an average magnitude of 5.6. Meanwhile, even greater worry is facing astronomers. The AST Space Mobile Aerospace Company has launched a satellite named Blue Walker 3, which now shines brighter than most stars at magnitudes between 4 and 0. The satellite is a prototype of the Bluebird satellite constellation. Its members will have even larger panels, will thus be even brighter than Blue Water 3. The planetary science community has come up with a prioritized wish list for the next 10 plus years in the field, a document that will help decide what missions NASA funds. Top of the list is a flagship mission to the ice giant Uranus, for now called the Uranus Orbiter and Probe. The full report comes in the form of the National Academy of Sciences Planetary Science and Astrobiology Decadal Survey, titled Origins, Worlds, and Life. The decadal strategy for planetary science and astrobiology for 2023 to 2032. It's a third prioritized wish list of its kind. As always, any mission concepts will still need to go through rounds of funding, design, and development before reaching the launch pad. This is a very, very interesting picture that was taken earlier this year from a fellow by the name of Elk Schultz out of Rio Hurtado in Chile. Captured a great image of the 5 bright planets on June the 15th, 2022. He wrote, "This morning I was lucky to observe the planetary party. The Andes Mountains can be seen in the background below Mercury. It features peaks more than 4,100 meters high. When I took the picture, Mercury had reached about 11 degrees. We have also discovered on July 9th mysterious X-ray flares on Jupiter that come from magnetic field vibrations. Jupiter regularly blasts out powerful flares of X-rays as part of its auroras, but how it does so has been a mystery since these bursts were discovered. Now researchers have finally figured out how they are generated. We found what we found wasn't any of the ideas that people had proposed over the last four decades since these X-rays were discovered, says William Dunn from the University College in London. He and his colleagues used data from the European Space Agency, XMMN, Newton Space Telescope on Jupiter's X-rays, and from NASA's Juno orbiter on the planet's magnetic fields to explain the phenomenon. They found that the X-rays occurred like clockwork once every 27 minutes, and they observed that the exact same timing in vibrations along the planet's magnetic field. You can picture the magnetic field of a planet like strings of a musical instrument, and the field can be vibrate like the strings on an electric guitar. Those vibrations are made up of waves of the magnetic field. Charged particles can get caught up in these waves and then smash into Jupiter's atmosphere, causing the X-ray pulses that we see. The planet just smashes the power cord out, and that vibration of the magnetic field carries the particles to the planet's poles. Understanding this phenomenon is important because it hints that the same sort of magnetic field vibrations may be crucial to some of the highest energy processes in the universe. X-rays are typically used to study really exotic, super energetic things like black holes, neutron stars, and the gas that flows between galaxies, things that are on the edge of the human imagination. The only way we can really understand how these places generate the X-rays is to go to more nearby places that do it, like Jupiter, says Dr. Dunn. We were celebrating this year 2 lunar eclipses, one on May the 15th and on 8 November. The lunar eclipses that was in May occulted actually Uranus. Now just one, but two the total greeted sky gazers, like we said, with the second one combined with the occultation of Uranus. I'm sorry, it was the second one. We won't see another total lunar eclipse until 2025, with only partial or penumbral events until then. And there we go. And these are some very, very nice pictures from the November 8th event, which I found that were very, very nice. It was a very pretty event. The Hubble Space Telescope is still working, of course, spied the most distant single star ever observed, faintly shining at about 28 billion light years away. This was on the 27th of September. The Hubble Space Telescope spied the most distant single star. The star existed just 900 million years after the Big Bang created the universe, and its light has traveled nearly 13 billion years to reach the Earth. Astronomers nicknamed the star Earendel, derived from the Old English word that means morning star or rising light. It is also known as WHL0137-LS, also known as Earendel, is a star in the constellation of Cetus, discovered in 2022 by the Hubble telescope. Is the most distant, earliest and most distant star. And again, there we go from there. Temperature's is greater than 20,000 degrees Kelvin. The apparent magnitude is about 27.2. And that's that. InSight ends. InSight lander's mission came to an end due to the surplus of dust on its solar panels and no whirlwinds to vacuum them clean, but the stationary spaceship made history in 2022. It detected the largest quake on Mars and captured the sounds of space rocks slamming into the planet, which created craters that revealed treasure troves of subsurface ice. The rover is setting up to a depot of samples that will be stored on the Martian surface. Samples will be retrieved and returned to Earth in 2033 via the ambitious Mars Sample Return Program, which will send a lander and a duo of retrieval helicopters to the Red Planet later this decade. NASA says goodbye to the first mole of Mars in December after the InSight lander stopped communicating with Earth. The robot landed on November the 26th, 2018, in the Elysium Planitia region to investigate Martian seismic activity and learn about the Mars interior and how it formed. InSight's power has been declining since the summer, and more dust because of the dust buildup. InSight has lived for more than lived up to its name as a scientist who spent career studying, and it's been a thrill to see the lander has achieved. And that was said by JPL Lori Leshin. Ah, yes, this was fun. Mars was occulted by the moon on December the 7th. And here are some photos of that event. Again, unfortunately, the moon was occulted by the clouds in the Midwest, so many people didn't get a chance to see it. The opposition of Mars on December the 8th meant that the red planet was once again big, bright, and beautiful in the evening sky. It wasn't quite at its closest point. What that happened a week before, a week before on December the 1st. But this year, opposition brought a special kind of magic in the form of occultation. The perfectly round orb contrasted beautifully with the shadowed craters of the moon, resulting in some unforgettable observations and imagery. Another big story this year, the Milky Way's black hole. Astronomers reveal the first image of the black hole at the heart of our own galaxy. This is a May 12th report. Astronomers have revealed the first image of the supermassive black hole at the center of our Milky Way galaxy. This result provides overwhelming evidence that the object is indeed a black hole and yields valuable clues about the workings of such giants, which are thought to reside at the center of most galaxies. The image was produced by a global research team called the Event Horizon Telescope Collaboration, using observations from a worldwide network of radio telescopes. The image is a long-anticipated look at the massive object that sits at the very center of our galaxy. Scientists have previously seen stars orbiting around something invisible, compact, and very massive at the center of the Milky Way. This strongly suggested that this object, known as Sagittarius A, is a black hole, and today's image provides the first direct visual evidence of it. Although we cannot see a black hole itself because of it being completely dark, glowing gas, around it reveals a telltale signature. The dark central region, called a shadow, surrounded by a bright ring-like structure. The new view captures light bent by the powerful gravity of the black hole, which is 4 million times more massive than our sun. We were stunned by how well the size of the ring agreed with predictions from Einstein's theory of general relativity, said project scientist Jeffrey Bauer from the Institute of Astronomy and Astrophysics, Academia Sinica, Taipei. These unprecedented observations have greatly improved our understanding of what happens at the very center of our galaxy and offer new insights on how these great black holes interact with their surroundings. The team's results have been published in the special issue of the Astrophysical Journal Letters. Because the black hole is about 27,000 light years from the Earth, it appears to us to have about the same size in the sky as a donut on the moon. To imagine it, the team created the powerful EHT, which linked together 8 existing radio observatories across the planet to form a single Earth-sized virtual telescope. The EHT observed Sagittarius A on multiple nights, collecting data for many hours in a row, similar to using a long exposure time camera. Breakthrough follows the EHT collaboration in 2019 of the first image of a black hole called M87 at the center of the most distant Messier 87 galaxy. The two black holes look remarkably similar, even though our galaxy's black hole is more than 1,000 times smaller than the less massive than M87. We have completely different types of galaxies and two different black hole masses, but close to the edge of these black holes, they look amazingly similar. This tells us that general relativity governs these objects up close, and any difference we see farther away must be due to the difference in the material that surrounds the black holes. This achievement was considerably more difficult than for M87, even though Sagittarius A is much closer to us. The gas in the vicinity of black holes moves at the same speed, nearly as fast as the speed of light, around both Sagittarius A and M87. But these gas takes days to weeks to orbit the larger M87. In the much smaller Sagittarius A, it completes an orbit within mere minutes. This means the brightness and pattern of the gas around Sagittarius A was changing rapidly, a bit like trying to take a clear picture of a puppy quickly chasing its tail. There's more to that story as well if you'd like it. And now we talk about the Artemis launch. The Artemis mission, one heads to the moon. After touch and go, and wet dress rehearsals, as they call it, months of delays, the first test flight of the launch system, and the Orion capsule went off without a hitch. Artemis was launched successfully and completed its trajectory, returning some stunning vistas of the Earth and the Moon from a vantage point we haven't seen in quite a while, before splashing back down into the Pacific Ocean. On the way, the mission also released 10 CubeSat missions to various orbits with mixed results. The Orion spacecraft for Artemis 1 was stacked on October the 20th, 2021, marking the first time a super heavy lift vehicle has been stacked inside NASA's vehicle assembly since the final Saturn V in 1973. On August the 17th, 2022, the fully stacked vehicle was rolled out to launch after a series of delays caused by difficulties in pre-flight testing. The first launch attempts were canceled due to faulty engine temperatures and a hydrogen leak during fueling during the September 3rd attempt. It was successfully launched on November the 16th. It is successfully launched from Launch Complex 398 at the Kennedy Space Center, and it was the first launch from LC-398 since Ares IX. The Orion spacecraft and the ICPS were both placed into nominal orbit after separating from the Space Launch System, achieving orbit in approximately 8 minutes after launch. Nearly 10 hours after launch, atop the world's most powerful rocket, NASA's Orion spacecraft snapped a selfie with Earth partially illuminated, visible in the background. This view of Earth, captured from a human-rated spacecraft, not seen since 1972 during the final Apollo mission some 50 years ago. These views are of our blue marble in the blackness space, now capturing the imagination of a generation, the Artemis generation. A portion of the far side of the moon looms large just beyond the Orion spacecraft. In this image taken on November the 21st, sixth day of the Artemis 1 mission via camera on the tip of one of Orion's solar arrays. Orion's moon crater close up on the sixth day of Artemis 1, November the 21st, the Orion spacecraft optical navigation camera captured a black and white image of the craters of the moon below. And on the final day of the Artemis mission on December the 5th, Orion captured the moon on the day of return, powered flyby, and final major engine maneuver of the flight test. And of course, at 12:40 on December the 11th, the Orion spacecraft for the Artemis mission splashed down in the Pacific after a 25.5-day mission to the moon. Comet Pan-STARRS on June the 25th. The comet C2017 K2 Pan-STARRS. Notably, this comet just reached its closest point to the sun on December the 19th, and it was visible in the southern skies. The DART mission on Tuesday, September the 27th at 6 p.m. Now it's up to astronomers to determine if this first planetary defense test was truly successful. From here on Earth, telescopes spotted the cloud of debris that was blasted off Dimorphos on impact. Also, following the impact, the tiny Italian CubeSat named Lycia Cube took close-range images of Didymos and Dimorphos, so the team could see what happened. Carried along the mission by DART, the cube was released to fly on its own on September the 11th, and it snapped pictures as it passed through the system shortly after DART completed its mission. At its core, DART represents an unprecedented success for planetary defense, but it is also a mission of unity with the real benefit for all humanity. NASA studies the cosmos from our home planet. We're also working to protect the home, and this international collaboration turned science fiction into science fact, demonstrated one way to protect the Earth. Launching on November the 2021, the DART mission had one purpose: as a kinetic impactor test. There are plenty of ideas for dealing with the dangerous asteroids, and the popular one in the science fiction has been to use nuclear weapons to destroy the space rock. Depending on how long we have until the asteroid would reach us, we may not need to resort to such drastic methods, however. The principle of kinetic impactor is simple enough. It is just a physical object that you smash into an asteroid at high speed. The result, hopefully, is that the asteroid is pushed into a different trajectory through space, one where it flies safely past our planet rather than hitting it. In the case of DART, NASA crashed the whole spacecraft into a 160-meter-wide Dimorphos. Asteroid moonlet Dimorphos was seen by DART spacecraft Draco camera 11 seconds before impact, 68 kilometers out. This image was the last to contain all of Dimorphos in the field of view. The purpose of this was to conduct the first real planetary defenses test to see if we could protect ourselves from an incoming asteroid. Currently, no known asteroids pose a danger to us. However, we may find one in the future. If we spot one in enough time to respond, we could launch a spacecraft like DART and crash into it. The goal isn't to destroy the space rock, instead to force the impact to nudge it to a safer orbit. The spacecraft was relatively small compared to its target. Still, the effect of DART's high-speed impact was greatly amplified by the 1,000 metric tons of debris blasted out into space as the spacecraft hit. In the process known as momentum transfer, the motion of each rock and dust particle flying away from the impact site added an extra bit of push on Dimorphos. It's this momentum transfer that NASA scientists say is most important for a small spacecraft to affect such a large object. Don't worry, though. Sure, for science fiction lovers will tell missions of going horribly wrong. However, DART only changed the length of time it takes Dimorphos to circle around its larger planet's asteroid. Didymos. Perseverance finds strongest signs yet of ancient life on Mars. On September the 15th, 2022, these potential biosignatures are an exciting discovery for the mission scientists. Exploring the delta front of the Zero crater, NASA's Perseverance rover was found the strongest signs of life yet, signs yet that life once existed on Mars. Are we alone in the universe? This is one of the most important questions that science has been trying to answer for us. Building on previous discoveries, the Perseverance rover is helping answer that question. If it found evidence that there was once life on Mars, a planet that was once warmer and wetter but is now very inhospitable, there is a good chance life is abundant throughout the cosmos. Perseverance is currently roving next to the ancient river delta on Mars, taking samples and using its instruments to scan the various rock deposits. Here on Earth, river deltas are teeming with life. Also, there are also places where signs of past life organic compounds become concentrated in the layers of sediment and rock as they build up over time. So if life did develop on Mars long ago, a river delta like the one in Jezero crater is just about the best place to look for signs of life. This map of the western edge of Jezero crater shows the path of Perseverance rover since its mission began on February the 2021. And the rover's current location is the red star. When the rover collected 2 of the latest samples from Skinner Ridge and Wildcat Ridge, it sent back some exciting results. While the rocks appear quite different, they both formed in a habitable environment. This is the conditions at the time and place that these rocks deposits were laid down were actually friendly to life as we know it. However, the fine-grained structure and light color of the Wildcat Ridge sample made it particularly interesting. These 2 abrasion patches shown the Skinner Ridge sample rock left, which is made of large grounded grains cemented together, and the Wildcat Ridge on the right, which is smooth and fine-grained. Both are exactly the kind of rocks NASA's looking for to find potential biosignatures. In the distant past, the sand, mud, and salts that now make up the Wildcat Ridge sample were deposited under conditions where life could potentially have survived. Perseverance Project scientist Ken Farley from Caltech said in the NASA release. Scanning the Wildcat Ridge abrasion patch using Sherlock, the scanning habitable environments with Raman and luminance for organics and chemicals, Perseverance detected treasure trove of organic compounds. In the Wildcat Ridge, we detected signals that we think are from a class of organic matter called aromatics, which are stable molecules made up of carbon, hydrogen, and sometimes other elements with ring structure. These signals were present in nearly every single point in every scan. They are also some of the brightest that we've seen so far on the mission, and they are about 7 times brighter than what we've seen in the Thornton Cap, which is an abrasion patch on Skinner Ridge. These are 2 abrasion patches show the Skinner Ridge sample rock, which is made of large ground grains cemented together, and the Wildcat Ridge sample rocks, which is smooth and fine-grained, as said. So there's some real good information from Perseverance. And the composite image of the delta, which puts the rover's latest samples into context, showing the locations of the Wildcat Ridge and Skinner Ridge sampling areas. The inset views show mosaic views from the rover of each after a sample was drilled from the rock. But that's what's truly exciting. Part of all this, Perseverance Sherlock instrument picked up some signs of organic matter in these rocks, while the rover has already found organic compounds in other areas of the crater. The Wildcat sample is a strong detection of organics so far. Signs of life? Maybe. Let's move on. September the 2nd, 2022, Friday, there was now one less thing to worry about when we finally send humans to Mars. It looks like the instrument called MOXIE has shown that it can reliably generate life-sustaining oxygen from the single carbon dioxide atmosphere of Mars, the thin carbon dioxide atmosphere of Mars. One of the most important considerations for sending humans to Mars is whether they will have the resources to live when they get there. The atmosphere of Mars is extremely thin, roughly 1/100th of the density of the Earth's atmosphere, but it is also primarily made of carbon dioxide, a gas that is poisonous to us. Future astronauts visiting the red planet will need oxygen on the ship that carries them there and back. They will also need a supply to sustain them during their stay on the surface, and even more will be required to launch them back into space at the end of the stay. We might want to point out, just as a side note, the trip to Mars will take 10 months and 10 months back, and they'll have to stay there for 2 years in order for the Earth and the Mars to line up to make a trip back. So the astronauts going to Mars will be there technically for 4 years. A lot of things can happen in 4 years. They will carry all that oxygen with me from the Earth to Mars. though, and will actually make the mission more difficult and more expensive. This is due to the mass and the weight of oxygen, as liquid oxygen is actually heavier than water. Thus, you need a bigger rocket or more trips to get all the extra mass into orbit from here on Earth. You need more thrust to send you on your way to Mars and more powerful rockets to safely land once you reach the destination. However, if you had a way to generate oxygen directly from the Martian environment, you could avoid all that extra mass and extra complications. That's where MOXIE comes in. To support human mission to Mars, we have to bring a lot of stuff from Earth, like computers, spacesuits, habitats. But dumb old oxygen, if you can make it there, go for it. You're way ahead of the game. MOXIE, or the Mars Oxygen in Situ Resource Utilization Experiment, is an experiment designed by the scientists at MIT and is currently installed in NASA's rover, as we said. Moving on. And now we get to the James Webb, which is the main theme of this particular presentation. Extend your arm, hold your hand up to the sky, raise your thumb. Your thumb will cover the whole area in this photo. Astounding. Practically everything in that photo, actually all of it, are galaxies. This, of course, is the Webb telescope. It also revealed an exoplanet atmosphere as never seen before. Excuse me, the next picture will be this is reveals an exoplanet atmosphere as never seen before. The atmosphere composition of the hot gas giant exoplanet WASP 39b has been revealed by NASA's Space Webb Telescope. This graphic shows 4 transmission spectra from 3 of Webb's instruments operated in 4 instrument modes. All are plotted on a comet scale extended from 0.2 to 0.5 to 5.5 microns. At the upper left, data from NIRISS shows fingerprints of potassium K, water HCO, and carbon monoxide CO. At the upper right, data from the CAM shows a prominent water structure, signature rather. At lower list, data from the Space Telescope indicates water, sulfur dioxide, carbon monoxide. The lower right, additional NIRSpec data reveals all of these molecules as well as sodium. The telescope array is a highly sensitive instrument, which was trained on the atmosphere of WASP 39b, a hot Saturn. The findings bode well for the compatibility of the Webb telescopes to conduct broad range of investigations on all types of exoplanets, planets around other stars, hoped for by the science community. That includes probing the atmospheres of smaller rocky planets like those in the TRAPPIST system. We observed the exoplanet with multiple instruments that together provide a broad swath of the infrared spectrum and a panoply of chemical fingerprints inaccessible until this mission. Data like this is game-changing. And this is the James Webb Telescope. Turns its gaze on the selection of more than 5,000 strange new worlds confirmed to exist in our galaxy. Scientists will begin to trace out a fuller picture of their lives from birth to death. This is the Carina Nebula in our Milky Way. One of James Webb's debut images was this cosmic landscape painting of the Carina Nebula, located about 7,600 light years from Earth. Lit up and sculptured by the radiation of baby stars, this is one of the most active star-forming regions to be discovered. Stephan's Quintet, a group of 5 tightly bound galaxies located 290 million light years away in the Pegasus constellation, is what happens when one part of the space gets too crowded. 4 of the tight-knit galaxies continuously loop past one another in a dangerous dance of near collision, slowly warping and stretching the stars between them. Southern Ring Nebula, a planetary nebula system seen by Web against the blackness of space with points of starlight behind it. Plumes of glowing bright blue gas radiate out of the oval-shaped nebula. Two separate ovals of reddish-pink gas appear stacked on top of each other inside a lacy blue gas clouds. In the center of the nebula, two stars glow close to each other. One star looks more red, while the other appears more yellow. Also called the Eight-Burst Nebula for its figure eight shape. The Southern Ring Nebula is a gargantuan cloud of dust expelled by a dying star some 2,500 light years away. James Webb imaged the stellar graveyard with two cameras, revealing more details in the nebula's gas structures in the left image and a secret second star hiding in the center of the right image. This is a shot of the Pillars of Creation. A ghostly shroud of dust cloaks the infamous Pillars of Creation in this showcase of James Webb's mid-infrared instrument called the MIRI. Unlike the more colorful view of the pillars shared earlier, the stars hidden within the dust clouds aren't bright enough to appear for MIRI, creating a spooky and somber portrait. Like a celestial nautilus shell, the eerie phantom galaxy swirls through space at about 32 million light years from Earth. Scientists call it the Grand Design Spiral, due to how prominent and well-defined the galaxy's spiral arms are. Cartwheel Galaxy, aptly named the Cartwheel Galaxy, located 500 light years from Earth, is a spectacular spiral galaxy shrouded in hot dust. Once it likely looked very similar to the Milky Way. However, an ancient collision with a smaller galaxy gave it its distinct wagon wheel-like shape. Ghostly Rings of Neptune. Saturn is the undisputed poster child for planetary rings, but in the gauzy James Webb image, Neptune gives the champ a run for its money. Neptune, the eighth planet from the sun, has 5 rings made of icy dust, which are rarely visible due to the planet's position on the far end of the solar system. Here they sparkle like crystals. Orion's Sword. Located just a few hundred light years from Earth, the Orion constellation is home to some of the largest and brightest stars in the sky, including the infamous red star Betelgeuse. This James Webb image ignores Orion's infamous belt to focus instead on its sword, where the Orion Nebula, one of the biggest, brightest star-forming regions in the sky, lurks. Take a look at that for a moment. Fiery Hourglass. A young star blasts streams of gas into surrounding dust clouds, creating a fire hourglass within the constellation Taurus. The Tarantula Nebula, stretching 340 light years across. The Tarantula Nebula stretches spindly legs of gas around the cosmic cavity carved by new stars. The eerie Einstein Ring. Like a cosmic bullseye, these trippy deep space object is called the Einstein Ring, named obviously for Albert Einstein, who predicted that massive objects in space could magnify or lens the light of objects far behind them. The eerily perfect circle is an illusion created by the warped space-time. Galactic collision. A pair of colliding galaxies called IC 1623 plunge into one another, igniting a burst of star formation. This chaotic process may well be creating a new supermassive black hole at the center of the two galactic behemoths. Knot of galaxies in the early universe. No less than 5 galaxies cluster together around an enormous ancient black hole known as a quasar. This cluster, located 11.5 billion light years away, is one of the most ancient objects imaged by the James Webb so far. Webb's first detection of an exoplanet. In this image, James Webb captures the first ever image of an exoplanet, or a planet outside our solar system. The planet, named HIP 65426b, is a gas giant up to 8 times more massive than Jupiter and located 349 light years from Earth. Jupiter's red spot. Jupiter's great red spot glows brightly in this rare James Webb image of our own solar system. Off to the left, Jupiter's moon Europa makes a cameo appearance. Jupiter in infrared, the James Webb Space infrared image clearly reveals Jupiter's thin ring. The moon's DB, Europa, Metis, and are in this, off of this picture a little bit. Bones of a spiral galaxy. This is IC 5332. This cosmic knot of gas, dust, and stars belongs to spiral galaxy AC 5332, located in the constellation Sculptor, more than 29 million light years from Earth. As it sits perfectly face-on with respect to Earth, its spiral arms can be seen incredibly clearly. And 6 points of light shine out of each star in this golden test image taken before James Webb's official debut. In the background, millions of distant galaxies grow. This article was edited on December the 5th to correct the typo suggesting that James Webb's image of exoplanet HB 65426 was the first image of an exoplanet taken. Rather, it's the first direct image of an exoplanet taken by JWST. And that's the end of James Webb. We have one more item to discuss, which I'm going to turn this over after I lead it to Dale Parton for a little bit more clear understanding. Nuclear fusion researchers have reached a historic energy milestone. A controlled fusion reaction was generating more energy than was put into the system for the first time, bringing viable fusion power another step closer to reality. For the first time on Earth, a controlled fusion reaction has generated more power than it was required to run, as said, researchers have confirmed. The experiment is a major step toward commercial fusion power, but experts say there is still a vast engineering effort needed to increase efficiency to reduce costs. Rumors of the experiment at Lawrence Livermore National Laboratory in California emerged on December 11th, but the news has been formally announced to the press conference more recently. In an experiment of 5 December, the lab's national ignition facility fusion reactor generated power output of 3.15 megajoules from a laser power output of 2.105 megajoules, a gain of about 150%. However, this is far outweighed by the roughly 300 megajoules drawn from the electrical grid to power the lasers for the first time. Today's announcements confirms that researchers not only reached the first crucial step, but surpassed it, albeit if you ignore the energy required to power the lasers. During the press conference, it was said that the lasers draw 300 trillion watts, much more power than the output by the entire U.S. national grid. And go ahead, Dale, you can jump in on this right now.
Okay. Well, as Ken mentioned, the claim was we reached break even. We got more energy out than the laser pulses that went in. What was not generally highlighted was it took about 100 times more electrical energy to generate those laser pulses than we got out in the way of energy output. There are a number of other things that are usually claimed about work on laser fusion, like it's going to be super clean and all of that stuff. There are some strong caveats to those kind of claims. What I've decided to do is put together a short presentation on this stuff, and I'll be presenting it again as a short presentation coming soon. So no question about it, it's a good step in the right direction, this development, but I would have to say it's been kind of overhyped, because the real efficiency, really we didn't get 1.5 times more energy out than we put in. If you look at the wall plug efficiency, we got something under 1% of the power out that we put in. Anyhow, thanks, Ken, for the good presentation.
Thank you, Dale, for your input. We really always appreciate that. You know, you're the scientist amongst us, and we appreciate that input. That is the in the news for 2022. Are there anybody else here that would like to add some report that wasn't included? Because there are plenty of them. And if there's one that was particularly outstanding, I'd like you to speak up now.
Wow, I'm having trouble even thinking about them. There are so many.
There really are a lot. I mean, you're talking about, like I said at the very beginning of this presentation, there were about, I would say, 30 spectacular things that happened this year in astronomy. And I just took the ones that seemed to have the public's eyes a little bit more. But again, I got a list of another 30 that if you want to talk about, we're certainly.
Wasn't the Bennu asteroid sample taken this year?
There's another one. There you go, right there. The Bennu sample came back as well. That's right.
I mean, I've got on my wall in front of me, I've got pictures ripped out of last year's NASA calendar. And one is there's Bennu, and there's the close-up of Bennu next to it. And I'm just like, and then I'm looking at all these other pictures, and I commented to Brother Guy that what an amazing time in astronomy and space. I mean, when I looked at the number. When I looked at the number of gravity wave observatories that are in existence right now, it's just amazing.
Well, I had fun putting this together, but like I said, Benno, I'm sorry I missed it. How do you like that? You know, that's right. That was another major story.
Well, asteroid fanatic. I mean, what can I say? Look behind me.
That's fine. That's fine. That's great. Any other questions or comments? You're certainly welcome. I'm here for you.
What do you think's gonna? What do the general audience here think is gonna happen with Artemis? Because that rocket costs what, $2 billion per shot.
Mm-hmm.
And it was developed at the same time that reusable rocketry was developed, and it does not include that. Is it going to? I mean, how many are we going to see all of the Artemises planned launched? Are they going to make changes because there's a better way to do it?
So good possibility. There's also the factor that you have to understand when you talk about traveling in space, you're talking about funding it. That seems to be, you know, when you hear the word funding it, the problem you have with governments is that it really isn't terribly very, very high thing on their list. I will tell you this. Take a look at just the James Webb. The James Webb was originally proposed to be a $500 million project. Do you know how much it finally cost? $10 billion. So you tell me. There you go. Who's going to want to spend that kind of money? I don't know. Can they sell it to the public? I don't know.
I know a few rappers that'll spend that kind of money.
Yeah, sure. I'm sure they will.
Space rappers. Hey, man, if they want to give their money to space exploration, I'm all for it.
Yeah.
That may be possible if they can write it off.
There's plenty of bazillionaires that could be spending the money on other things.
Well, a couple of them have their own space program that they're funding. So that's where it's all going.
Well, I enjoyed doing it. And if you have any other questions or something, you can call me. You can send me an email, anything you like. I'm good with it.
If you're on Facebook, Ken's there on Wednesdays.
Yeah, on Wednesdays, I do Astronomy of the Week. I enjoy the heck out of doing it, and I'm getting more and more returns from it. I do have my own site on Facebook as well. I get more responses from that than I do on the general public, but the people that answer that are usually astronomers anyway, so that's different than those that aren't. And it's raising a lot of interesting responses from the people. They really like it. And again, thank you very much for having me tonight. Back to you, Dale.
Well, thank you, Ken, for doing that. And far as I know, that's everything we had to cover tonight.
Yeah. So at this point, if we were at Cranbrook, typically what we'd be doing is trying to hightail it out to come on.
Redcoat.
Thank you, Redcoat Tavern, and doing some gastronomy. But since we're all at home right now, you can go into your refrigerator and grab a munchie. One thing I failed to mention is we are having trouble getting hosts for our discussion groups, our in-person discussion groups, for obvious reasons. I was wondering if the membership would be interested in attending even a short online, just another WebEx, just get together and just chat about astronomy and stuff. I'm going to be sending out a letter to the membership. I'd like to know if anybody would be interested in attending an online discussion group just to chat.
Depends on the date.
That one of the things I had to determine in the mailing is when we want to do this. Typically, I think where we'd be scheduled for Tuesday, the 24th, but any time that week would be fine. So at this point, I think we're done with our program. We will be meeting again the third Thursday. This will be our virtual Macomb meeting, so we'll be online again. Thank you everyone for attending, and have a good evening. Good
Great
night,
seeing you
all.
guys. Happy New Year.
Happy New
everyone.
Year.
Happy New Year, everybody.
Happy New Year.
Happy New Year.
Thanks, Ken.
You're welcome, pal.
All right.
Another
Those,
6 months, you'll have another 1,000 stories.
those who stayed get to see me at my
Finally, hi, Adrian.
yeah. This is
Adrian,
my